Welcome back. Section 6-7 Hyperbolic Functions. Here are the definitions of hyperbolic functions. Sine hyperbolic of x is e raised to x minus e raised to negative x the whole over 2. So it is difference of exponential functions, half of that. Okay. Sine hyperbolic x is e raised to x minus e raised to negative x the whole over 2. Cosine hyperbolic of x is e raised to x plus e raised to negative x the whole over 2. Tan hyperbolic x is sine hyperbolic x divided by cosine hyperbolic x. So numerator and denominator. You see the 2's get cancelled. E raised to x minus e raised to negative x divided by e raised to x plus e raised to negative x. That's tan hyperbolic. Cosecant hyperbolic. This is 1 over sine hyperbolic. In other words, take this and take its reciprocal. 2 divided by e raised to x minus e raised to negative x. Secant hyperbolic. Secant hyperbolic x is 1 over cosine hyperbolic x. So you take this and take its reciprocal, 2 over e raised to x plus e raised to negative x. Cotan hyperbolic. Cotan hyperbolic x is reciprocal of tan hyperbolic, 1 by tan hyperbolic. So you take reciprocal of this, which is a reciprocal of this, e raised to x plus e raised to negative x over e raised to x minus e raised to negative x. Now, let us look at a few graphs. E raised to x is this blue curve. E raised to negative x is this red curve. You see, it's a reflection of e raised to x. Sine hyperbolic is actually difference between the 2 over 2. So e raised to x minus e raised to negative x, the entire thing over 2. And this is how sine hyperbolic looks like, the black curve here. So one thing you notice, it is 1 to 1. Moreover, it is defined over the entire number line. Cosine hyperbolic x. Cosine hyperbolic x. You take e raised to x, e raised to negative x and average of the 2. That is this plus this over 2. So the black curve here is cosine hyperbolic x. Okay. It is positive valued. Alright, defined all over number line. Tan hyperbolic x. Tan hyperbolic x is sine hyperbolic x divided by cosine hyperbolic x. So this is how it looks like. Okay. So notice tan hyperbolic x is defined for all numbers in the number line, but it doesn't go beyond, the value doesn't go beyond 1 or negative 1. So the range of tan hyperbolic x is negative 1 to positive 1, open. Moreover, from the graph you can see limit x approaching infinity of tan hyperbolic x is 1. So y equals 1 is a horizontal asymptote. Likewise, limit x approaching negative infinity of tan hyperbolic x is negative 1. So y equals negative 1 is also a horizontal asymptote. Now here are identities. Sine hyperbolic of negative x is negative of sine hyperbolic x. Cosine hyperbolic of negative x is cosine hyperbolic of x. That is, cosine hyperbolic is an even function, whereas sine hyperbolic is an odd function. Moreover, cosine hyperbolic squared of x minus sine hyperbolic squared of x is 1. 1 minus tan hyperbolic squared of x is secant hyperbolic square of x. Some formula. Sine hyperbolic x or sine hyperbolic of x plus 1 is sine hyperbolic of x cosine hyperbolic of y plus cosine hyperbolic of x sine hyperbolic of y. Cosine hyperbolic of x plus y is cosine hyperbolic x times cosine hyperbolic y plus sine hyperbolic x times sine hyperbolic y. So these identities, they are similar to what happens in trigonometric identities. Similar, okay? This would be a plus. This would be a plus. This is fine as it is. This would be a minus, okay? So anyhow, let's continue with proving this. Example 1. Prove the identity sine hyperbolic of negative x is negative sine hyperbolic of x. Well, what is sine hyperbolic of x? It is e raised to x minus e raised to negative x by 2. Therefore, what is sine hyperbolic negative x? Wherever I see x, I place negative x in this formula. So e raised to negative x minus e raised to negative of negative x, the whole over 2. When you simplify, notice this one becomes e raised to positive x. So e raised to negative x minus e raised to x. So if I need to flip these around, you see, sine hyperbolic x has e raised to positive x first. So if I need to flip this around, I incorporate a negative outside. And that's how sine hyperbolic of negative x is negative sine hyperbolic of x. That's because when you flip these two, you incorporate a negative outside. Next identity. Cosine hyperbolic of negative x is cosine hyperbolic of x. Note, cosine hyperbolic of x is e raised to x plus e raised to negative x by 2. So what is cosine hyperbolic negative x? Wherever I see x, I replace it by negative x. So that gets me e raised to negative x plus e raised to x by 2. Because it is a plus, I can flip these two and it should be a plus here. Okay. I'm unable to fix it, but this should be a plus here. So when I add, I get cosine hyperbolic x back. Okay, so this should be a plus here. Next identity. Prove the identity cosine hyperbolic squared x minus sine hyperbolic squared x is 1. So what is cosine hyperbolic squared? It is e raised to x plus e raised to negative x by 2 power 2. Likewise, what is sine hyperbolic x squared? E raised to x minus e raised to negative x by 2 power 2. So difference is a difference. All we are going to do is complete square, right? So 2 squared, denominator is 4 in both of these cases. Numerator, square of the first, 2 times first and second, plus square of the second. So notice this times this is a 1. So all I'm left with is 2 in the middle. Minus, same story, square of the first, minus 2 times this is, plus square of the second. Common denominator is 4, e raised to x plus 2 plus e raised to negative 2x, and notice this minus will distribute to the right. So negative e raised to 2x, positive 2, negative e raised to negative 2x. So let's see what happens. This gets cancelled by this. This gets cancelled by this. All I'm left with is 2 plus 2, 4 over 4, which is an overall 1. Okay, so you have proved this identity. Likewise, let's prove the identity 1 minus tan hyperbolic squared x is secant hyperbolic squared x. 1 minus tan hyperbolic squared x is 1 minus sine hyperbolic squared x over cosine hyperbolic squared x. That's because tan hyperbolic is sine hyperbolic over cosine hyperbolic. Well, common denominator is cosine hyperbolic squared. Multiply this by cosine hyperbolic squared minus sine hyperbolic squared as above. But we just saw cosine hyperbolic squared minus sine hyperbolic squared is 1. So the numerator is simply 1. Now 1 over cosine hyperbolic is secant. So 1 over cosine hyperbolic squared is secant hyperbolic squared x. So you got the identity you wanted. Fifth identity, prove the identity sine hyperbolic x plus y equals all of this, right? So sine hyperbolic x plus y is e raised to x plus y minus e raised to negative of x plus y by 2. Split this e raised to x, e raised to y minus split this e raised to negative x, e raised to negative y over 2. So multiply numerator and denominator by 2. So 2 distributes to the top, 2 multiplied to the bottom is 4. So all I have is the same expression as above, except I have distributed, multiplied numerator by 2 and denominator by 2. Now, why would I do that? E raised to x, 2 e raised to xy, I've written it as e raised to xy plus e raised to xy. Likewise, negative 2 e raised to x, negative x, e raised to negative y, I've written it as negative e raised to negative x, negative e raised to negative y. So those two took care of the numerator as it is. I have added something here. Notice e raised to x, e raised to negative y. Whatever I have added, I've subtracted. Likewise, e raised to negative x, e raised to y. I have added this, so I have subtracted. So what have I done? I have added 2 zeros. That's it. No change. It's just a gimmick. Okay. You will see in a minute why I do this. So 4 is 4. Now let's start rearranging. E raised to x, e raised to y, e raised to x, e raised to y. You see, rearrange. Bring this here. Bring this here. One of these here. You see, 1, 1, 1, 1. So we have brought those 4 things here. And the rest together here. Now, what's the point of this? If you notice, we are simply combining things here. You know, all of this turns out to be this times this, this times this. You can check. All we are doing is distributing. E raised to x, e raised to y. E raised to x, e raised to negative y. E raised to negative x, e raised to y. E raised to negative x, e raised to negative y. You see? So that's all. What is this? Sine hyperbolic x. What is this? Cosine hyperbolic y. What is this? Cosine hyperbolic x. This is sine hyperbolic y. So it's simple calculations. The last identity, cosine hyperbolic x plus y, equals cosine hyperbolic x, cosine hyperbolic y. That should be a plus. Cosine hyperbolic x, cosine hyperbolic y. That should be a y, and that should be an x. Okay. There are a few typos, but leave that. I will leave that for you to check. Okay. I'll stop this video now and continue with the next.